Hello, my name is Mr. Chonyo. Welcome to my study room. Today we are solving objective questions 5, 11, 17, 21, and 29 of the 2023 WASSCE Further or Elective Maths paper written by Ghana. I choose to put these questions together because they are all around the same concept, which is calculus. So these questions are going to be about differentiation, integration, and their applications. So we move on straight to question 5, which reads that if f of x equals 1 plus 2x minus 3x squared, find the value of x for which f of x is maximum. I'll first start by rewriting our question and first changing the f of x to y because they are the same. So let me rewrite this as y equals 1 plus 2x minus 3x squared. And in fact, this question is an application of differentiation. So what we need to know about this question is that at the maximum, dy dx equals 0. So let me write that. So what this means is that since dy dx equals 0 at the maximum, we are going to differentiate this with respect to x. And whatever answer we get, we equate it to 0 and solve for x. And that is what is going to be our answer. So let's go ahead and do that. So this is y. And dy dx is going to be, when we differentiate a constant, we get 0. So we can decide not to write, or we write 0 for the sake of the process. Then plus, when we differentiate an x term, it gives us a constant. So the differential of 2x gives us 2. And then this comes to multiply this to give us negative 6. And the exponent of x reduced by 1, so that will give us x. And then I'll rewrite this, but I would like to put that in the next process where we equate dy dx to 0, and that gives us 2 minus 6x equal to 0. And then we solve for x now. By adding 6x to both sides, you're going to get 2 equals 6x, and dividing both sides by 6, you're going to have x equals 1 over 3. And looking through the possible answers, that becomes option B. We move to the next question, which is question 11. Question 11 is a definite integral. We are finding the integral of x cubed plus 1 all over x squared with respect to x for the boundaries 2 to 1. Again, because this examination is calculator active, meaning that calculator is permitted in the exams, we don't need to work out anything. So I'm just going to put this into the calculator, press equal to, and then choose our answer. So let's get onto the calculator quickly. So we have our calculator. We use the definite integral symbol, which is here. So I press this, and then I go to my parentheses first. So open parentheses, and then I bring the fraction sign. I go to alpha, x is here, cube, I use this, and then type in 3. Remember to bring the cursor forward by using this. Then I bring the plus 1 all over. So I use the down key, alpha x squared here. Then I use the forward arrow key. I close my parentheses, and I come back to the down limit, which is 1. And then I move the cursor up and then put 2 here, and I press equal to, and that gives me 2, which is the same as option D, 2.0. So I'm not going to do anything else. I just choose my correct answer, 2.0 here, option D. Let's move on to the next question, which is 17. 17, just like 11 that we solved earlier, also calculator question. So we're just going to punch everything in the calculator just as we see it, and then we press equal to and choose our answer. So let's get onto the calculator quickly again. My previous work is still on it. I can decide to edit this, or I start all over by pressing AC. Then I go to the integral sign. Then I bring my parentheses. I have 4 minus 2x. I have to go to alpha and x to get my x. then I close my parentheses first, I open another one, then I have x, so I have to go to alpha x plus 3. Then I close it, I move the cursor forward to the limit. I have 0, the minimum, and then the maximum is 3. Then after that I punch equal to, and that gives me 9, which is the same as option B. So I'll just go here and choose option B. That's the correct answer. We move to 21. So question 21 says that the gradient function of a curve which passes through the point P with coordinate -1, 2 is 3x squared plus 7x minus 3. Find the equation of the curve. So the key point we need to pay attention to here is gradient function. And what is that? Gradient function is simply the first derivative of a curve. So if we have a curve which is y equal to something and you differentiate it to get the y dx, whatever answer you get becomes the gradient function. And if you plug in or substitute the coordinate of x and y of the point given into it, that gives us the gradient of that curve at that point. But this time, that is not what we are being asked to find. We are to find the equation of the curve. So the question says that the gradient function of the curve is this one. So that means that what it means to us right now is that dy dx equals 3x squared plus 7x minus 3. That is what it means. The gradient function is the derivative of the original function or the original equation. If this is dy dx, then it means that if we integrate this, it gives us the curve back. So that is what we are going to do. We are going to do the inverse because it was the curve that was differentiated to give us dy dx. So when we integrate, which is the reverse of differentiation, it gives us the curve back. So that's what we're going to do. And I'll try to slow down and take that slowly for the sake of those who might not know what is happening. So again, when we integrate this, it gives us y. When we integrate dy dx, it gives us y. So we write y equals, now we are going to integrate this, which is the reverse of differentiation. So first of all, we are going to add 1 to this, exponent 2 here to give us 3x exponent 3 because of the 2 plus 1. Then whatever we get here, we'll be dividing the whole thing. So that gives us over 3. Then now we move to the second term. We have this, the exponent is 1. When we add 1, it gives us 7x squared. Then we use these 2 to divide. So all over 2. Then minus, we have 3 here. This is the same as 3x exponent 0, but it's just not showing. X exponent 0 is 1. And 1 times 3 is 3, but it's just not showing. So when we add 1 here now, it becomes 3x exponent 1, which is the same as 3x. So that's what we'll be having here. So we have 3x here over 1 is the same as 3x. So we not write that. Then plus a constant c, which we'll be working for. And just for us to rewrite this, this is going to give us y equal to x cubed, because 3 over 3 is 1 plus 7 over 2x squared minus 3x plus c. Then at the point P, -1, 2, wherever we see x, we are going to put -1. Wherever we see y, we are going to put 2. And that will help us find the value of c. Actually, that's why we are doing this. So we are going to substitute -1 and 2 into this, and then that will give us the value of c. After that, we come and substitute the c with whatever value we get, and that gives us the equation of the curve. So let's go ahead and do that. Like I said earlier, wherever we see y, we put 2. So 2, this now becomes 2 equals -1 cubed plus 7 over 2 multiplying -1 squared minus 3 multiplying -1 plus c. And that gives us 2 equals -1 cubed is -1 plus 7 over 2, because negative 1 squared, you must remember to put it in parentheses, is 1 times 7 over 2 is 7 over 2, then plus 3. I forgot to bring the 1, so 1, negative 3 times negative 1 is positive 3, then plus c. Solving this further, we get 2 equals, when you put all of this into your calculator, you are going to get 11 over 2. All you need to do is to put it into a calculator, well, then plus c. Then subtracting 11 over 2 from both sides, we are going to get 2 minus 11 over 2 equal to c. And if we do that with our calculator, well, we should get our c to be equal to negative 7 over 2. For the sake of our space, let me just rewrite this equation here now, because now we solve for the value of c, which is the reason why we are doing that. So now the equation of the curve now becomes y equals x cubed plus 7 over 2 x squared minus 3x, then minus 7 over 2, because remember we got c to be equal to negative 7 over 2. So that is what I'm using to replace this c here. Don't forget that. And looking at the options here, there is no fraction. So we are going to multiply it through by the denominator, which is 2. So 2 times this gives us 2y equals 2x cubed plus 7x squared, because the 2 be gone, minus 6x minus 7. And this becomes our answer. And by looking through, that is option B. We move to the last question for this study, which is question 29. Alright, so 29 reads that if y squared plus xy minus x equals 5, find the y dx. This looks very simple, but for the y squared and then the xy here, and that's likely to be a problem for those who might not know how to do implicit differentiation or differentiation of implicit functions. So I'm going to take my time to go through that gradually. And just a little background for those who might not really know what implicit differentiation is talking about. Under normal differentiation, we have a normal curve y equal to a function with respect to x. That means y will be equal to a function that has only x as a variable in it. And then when you differentiate the y, you get the y dx, and then you just differentiate the x, and then you move on. But in the case where we have more than just one y, or y with exponent 1, we use what we call the implicit differentiation, where every y we differentiate becomes the y dx, and then we apply any other rule, the chain rule, the product or quotient rules, depending on what the question is requiring us to do. So that is what we are going to do now, and I'm going to rewrite my question, then I start the differentiation as I explain along. Yeah, so I have my question here, and I'm going to differentiate each term with respect to x. After that, I make the y dx a subject. That's what we're going to do. So we start to write with the y squared. When we differentiate a y, remember we are differentiating everything with respect to x. First of all, we have the same idea. So differentiating y gives us 2y, meaning the 2 drops here, the exponent reduced by 1. But then we need to attach the y dx to our differentiation. Then plus, remember what we have here is a product, which is x multiplying y. So to differentiate this, we have to use the product rule, which says that if this is the first function u and this is another function v, then to differentiate both of them, which will get dy dx will be equal to v du. Some will still write dx, but I like v du, which simply means you keep v and differentiate u plus u dv. Then again, some will still write the x, meaning that with respect to x. But the most important thing is that you keep the second one, which is v, and differentiate u. After that, you keep the first one, which is u, and differentiate v, all with respect to x. But some still write the u dv first, because addition obviously is commutative, so it doesn't matter which one you bring first. So that is what I'm going to do right now. So with this, I keep the second one, which is v, so I write y. Then when I differentiate x, I will get 1. So that still keep my y, then plus this plus here. I keep the first one, which is x. When I differentiate y, I get dy dx. Then minus, when I differentiate x, I still get 1. Remember, this one is y times 1, but it's just 1. That's why I didn't write the 1. If you like, I can still bring the 1 here. But then it's just y times 1, which is y. Then equals to the differential of a constant is 0. Then remember I told you earlier that we have to group the dy dx terms and make dy dx the subject. So let's do that quickly. This gives us 2y dy dx, then plus x dy dx plus y. I just move it to here, minus 1 equal to 0. Or better still, so that I don't waste too much time, I'll just move this to the right of the equal to sign at once. So let me do that. So this will be equal to, let me bring the positive term first. So negative 1, when it comes to the right side, becomes positive 1. Then when positive y comes to the right side, it becomes negative y. Then when we factor dy dx out, I'm going to have dy dx, because it's a common term, multiplying 2y plus x. And that will be equal to 1 minus y. And dividing both sides by 2y plus x, I'm going to get dy dx to be equal to 1 minus y all over 2y plus x. And when we look at the possible answers, these two are the ones that come closer, and in both of them the x comes first because addition is commutative, of course. So I can rewrite this as 1 minus y over x plus 2y. And looking through, that is option C. And that is where we bring today's lesson to an end. I hope this lesson has been of help to you. If yes, then why not consider subscribing to this channel for more videos like this. Till I meet you again in my study room. Bye bye.